Hey, what's up everybody? I'd like to welcome you to another Juice tutorial. And in this tutorial, what we're going to do is we're going to actually implement a ADSR object. So that's an envelope object into our sampler where we're actually going to be able to control the shape of our sound using parameters from the sliders that we set up in our last tutorial. So a very quick reminder that we have the Patreon for people that want to support the audio programmer. Be sure to check us out on patreon.com/the audio programmer. And also we have merchandise. So if you want to code while drinking from your audio programmer mug, or if you want to sit in the sun with your audio programmer t-shirt, be sure to check out the merchandise right below this video. So let's go ahead and get started. One of the first things that I'll tell you is that we implemented a slider listener class in our last tutorial, and this is great for just getting things connected very quickly to test them. But in order to really have that robust type of behavior when we're actually releasing a product, we actually want to replace this slider listener class with an audio processor value tree state, which I mentioned before. I have some tutorials where I show you how to actually use it, and I'm going to show you how to replace all of this again in a couple tutorials. But for now, what we're going to do is we're going to just implement the ADSR so we can actually control the shape of our sound, and we'll be able to do that using this slider listener class. So going back to our plugin processor header file, we have these variables that we created: attack, decay, and sustain and release, and we have our sliders that we created. So we have these dials that correspond to those parameters, and they're mapping to those. Okay, so now what we need to do is we need to create an ADSR where we can actually use that to control these sounds. Okay, what we'll find is that if we go to the sampler sound class, then you will actually see that there's actually a method in here that says set envelope parameters, where we can just insert the parameters that we want to use, and that this will automatically update. And this is something that Zanakios from the Juce Discord actually pointed out to me the other day, because I was doing a live stream where I thought, okay, if I implement an ADSR object into my synthesizer class, that's how I use it to control the sounds. And then he said, are you aware that sampler sound actually has an ADSR already inside of it, and you can just actually control it with the ADSR parameters? And I thought, wow, I didn't know that. So that makes our job much easier, and we just need to know a little bit of C++ to actually get back to these sounds. So just doing a really quick review, we have this method where we're loading a file. So this is what happens where we actually take an audio file, we drop it into the plugin window, and it's loading this file. It's creating a reader for it where we're actually able to stream audio. And then from there, it adds the sound to our sampler. So it says here that we have this new sampler sound, and then we're telling it, we're just giving it the reader for our audio file. So if we click into the sampler sound and we go to jump to definition, what we will see, if I just search for ADSR, we will see that there's actually in private, we have this ADSR object that's created that's within the sampler sound. So any sound that we create for our sampler, it actually has its own ADSR object. So we don't have access to the ADSR itself because, as we can see, it's in private, but we do have this method called set envelope parameters, where we're actually able to update that ADSR and the parameters. Okay, so all we have to do is we just need to say, hey, if we're changing the attack, we just say parameters.attack is now 3 seconds, and then we just put that into our ADSR, and it works like that. So now the challenge becomes, okay, when we're trying to actually update our ADSR, how do we actually access these sampler sounds so we can update the actual parameters? Okay, so we need to use a little bit of kind of intermediate C++ to actually be able to do this. Okay, so I'm going to explain this to you the best that I can, and hopefully this will be, hopefully this will work. Okay, so first thing that we need to do, so the logical thing would be that if we have all of these sampler sounds, so in this case we only have one, what we need to do is we actually just need to iterate. We need to go back into the sampler because that's what contains the sounds, and we actually need to go and try to get these sampler sounds, right? So if we go back to prepare to play, this sounds simple enough so far, right? So I say for I equals 0, I is less than M sampler, get num sounds. Okay, so we're going and we're getting the number of sounds that are in our sampler. Now, what we could say is we could start off and we could say M sampler get sound I, right? So that's fine for now. Now here's where it starts to get a little bit tricky. If we look at M sampler, what we'll see is M sampler is of type synthesizer, right? So synthesizer, so a synthesizer just generally refers to something that could play a sound. Now we have two different classes that kind of use that synthesizer class. We have a synthesizer sound and we have a sampler sound, right? So a synthesizer, so a synthesizer object can hold either a synthesizer sound or it could hold a sampler sound. So that brings up a question. When we're getting the sounds from our sampler, how does it know whether the sound that we're getting is a sampler sound or a synthesizer sound? And the answer is that it doesn't. So what we need to do is we need to check to make sure that the sounds are actually sampler sounds, okay? And the way that we could do that is we could use what's called dynamic casting in order to do this, okay? It's a little bit tricky to use, but I will show you how. So what we could do is we could say if, and we'll create a sound variable, and what we'll do is we'll essentially try to cast our sounds that we're getting from our synthesizer, and we're going to try to cast them as sampler sounds. And we're going to say, if we're able to cast this as a sampler sound, then we know it's a sampler sound if it works, and that we will be able to do what we need to do with it, okay? So what we could say is if sound equals dynamic cast, and then we want to say sampler sound pointer, okay? And now we get into the next kind of tricky part of this, okay, where we say, okay, get the sound, see if it's a sampler sound. Okay, then we get this one, right? We get this little error where it says synthesizer sound pointer, aka reference counted pointer, object pointer is not a pointer, okay? So what it's saying here is that it's giving us the reference counted object of pointer of type Juce synthesizer sound, but that's not the pointer itself, okay? In order to get the pointer itself, we need to use the get method, okay? So the get method is what actually gives us the pointer itself, okay? So that's what we're doing there. Okay, so I'm going to explain this one more time just so everybody can understand, okay? Because it took me a while to understand this myself. So we have a synthesizer class, right? So it's a that we've called sampler. Now, so when we loaded a file, when we loaded our new sound, we created a sampler sound, okay? Now, when we go back to get the sounds again, okay, so that's what we're doing. We're saying, okay, go through, find out how many sounds we have in this sampler and go and get them. And now, once again, we come to the question of, are these sounds that we're getting, are they synthesizer sounds or are they sampler sounds? Okay, we can see that sampler sound is a class that derives from synthesizer sound. Okay, so the difference between these two classes is that if we look at sampler sound, we see that we have methods that are sampler sound methods, mainly this one, set envelope parameters. Okay, that's the reason that we need to make sure that it's a sampler sound, because we have this method called set envelope parameters. But if we look back at the synthesizer sound class, we will see that there's no method called set envelope parameters. There's no such thing, right? That's why it's important for us to make sure that we have the right object, okay? That's why we have to make sure that we can cast this as a sampler sound. And that's what we're doing here, okay? So we're saying, make sure this is a sampler sound. So because we're about to do this method, and it'll only work if it's a sampler sound. If it's a synthesizer sound, then it will not work. It'll probably crash or something would go wrong with it. Okay, so that's why we're using dynamic cast here. So we will see that I can do now sound, which is a sampler sound pointer. Now I have this method that's called set envelope parameters. And now I can put, well, I don't actually have an ADSR parameters object yet. Let's create one really quick. So I'll do ADSR parameters and ADSR params. Okay, and I'll come back and I'll explain this very shortly. So I'll put this in here for now. Okay, so going back to my original point, which is that if I went outside of this, right, and I said sampler get sound get, right, and I don't try to dynamic cast it, what I should be able to do is we will see that when I tried to access or do autocomplete for the methods, there's no method here that I can use to autocomplete that says set envelope params. That's because this doesn't know whether it's a synthesizer sound or a sampler sound. Okay, but we'll see that it gets some of the other methods, applies to note, applies to channel. We'll see that those are methods that apply to both synthesizer sound and sampler sound, right? But set envelope parameters only applies to sampler sound, but there's no such thing in synthesizer sound. So just trying to explain in a couple different ways why we have to use dynamic casting there to actually make sure that that works. Okay, so now that's fine, and that updates our parameters. Okay, so now let's go and let's talk about the ADSR parameters themselves. Okay, so ADSR parameters, if we go over here to the documentation, we will see that the ADSR parameters holds our attack, decay, sustain, and release times. Okay, and because of that, we'll be able to actually get rid of this eventually, attack, decay, sustain, and release. And now we just need to map it to the parameters of those same names. Okay, so now what we need is, okay, we have this, we go and we update our ADSR parameters when in prepare to play. Now we need to do the same thing when we have a change in our slider. So when the user makes a change in the attack, decay, sustain, or release sliders, we need to go through the sounds, and we need to say, hey, update your parameters because the users just changed their attack time. Okay, so what we're going to do is we're just going to change things around a little bit, where what I could do is I can just copy this for a moment, and here we'll use this method that says get ADSR value. What I'm going to do is I'm just going to change the name of this to update ADSR. Okay. And then in here, I'm going to put the code where we actually, so then when we're updating our ADSR, we're going through our sounds and we're updating our ADSR by setting the envelope parameters in our sampler sounds. Okay. Now it's saying it doesn't match any declaration. That's because we got to go back and we got to change this. So this we've renamed to update ADSR. Okay. And now what we need to do is we can now go up here to prepare to play. And now we put all this code over in update ADSR. And now I can just say that. I can just call that method there. Okay. Now we need to be able to call this update ADSR when we change a slider. So this slider value changed calls whenever we update whenever we're changing the slider. Okay. Now we can see that update ADSR is in the public section of our processor. So here in plugin editor, down here at the bottom, the user makes a change. We see what change they made, and then we could just say processor update ADSR, and then we update the ADSR. Okay. Now at the moment, these are mapping to these kind of dummy parameters that we've set up, and now we need to replace those with our attack, decay, sustain, and release parameters from this ADSR parameters object. Now our ADSR parameters object is in private. Okay. And what we could do is we could just use a little get method. Okay. So what I could do is I could say ADSR parameters, and we want this to be a reference. And then we could say get params, get ADSR params. And then what I can do is I can return our ADSR params object. Okay, so you see we're using a reference. We don't need to make a copy of this ADSR parameters object. Okay, we already have one of those, so no need to make another copy of it. So that's why we're using a reference there. Okay, because we're referring to this exact object that we've created. Okay, now we can use that to access the actual parameters themselves in the editor. So what I could say is instead of processor.attack, I could say processor get ADSR params attack. Okay, because attack is a member variable of this ADSR params. Okay, so that's how we're accessing that there. Okay, and then we're doing the same thing here. Okay, just for decay, processor get ADSR params decay. And then same thing for sustain. So we've got get ADSR params sustain, and get ADSR params release. Okay, so those are now mapping to our actual ADSR params. Then anytime that this changes, once this exits, then it will update our actual ADSR. And then going back to our ADSR, our update ADSR method, we see that it goes through the sampler sounds, tries to cast them as sampler sounds, make sure that they're sampler sounds, and it sets the envelope for those. So let's go ahead and compile that. And we got a build failed. So what did we do? Get ADSR value. Oh, that's a method that I called in my audio callback that we don't need anymore. Okay, because we don't need to call this continuously through the process block, right? We only need to call update parameters when we are actually making a change in our ADSR itself. So now we have hello sampler. So once again, like I was explaining to you before, this slider listener class that we've implemented, this isn't the best class to keep things in sync. So what we'll see is that it only works when it only updates all of our parameters once we've turned one of the parameters themselves. Okay, so let's use a fairly like a synthesizer sound where we can hear a release. I'm looking for one here. So we got the synth chord. Okay, so let's drag that in. So it drags in. We'll see that this will disappear as well. We'll fix that a little bit later. So now I can play it. Okay, and now I'll just set the attack to 0. So we can hear that that's got the attack now. And so let's mess around with this. Okay, so now we hear that it has the release now. Just gonna turn this down a little bit so it doesn't blow everybody's eardrums out. Okay, so I'm releasing the key. We see that it has the release. Okay, now let's try to turn this down. Let's give it a little bit of sustain. Okay, and we can see that we can also get that plucky type sound as well. Right? Or if I turn the sustain up, it sustains. So we can see that this works now. Okay. So that's pretty much it for this tutorial. So yeah, so just the main thing to keep in mind is that when you have something where we have a class and we need to determine what class it is because it might have a method that we're trying to use from one of the derived classes, we need to make sure that we use dynamic cast. So in the next tutorial, what we'll do is we're going to take this slider listener class that we implemented and we're going to actually change this and update it using the audio processor value tree state class. Okay, so I hope you enjoyed this. Be sure to give it a thumbs up and I will see you next time.